Hello. In this podcast, I will give you information about Albert Einstein's theory of relativity. After listening, you will have learned some quality things about relativity. Let's start. Albert Einstein's theory of relativity is one of the most famous and influential theories in the history of physics. It fundamentally changed the way we understand the nature of time and space, and it has had a profound impact on fields ranging from astronomy and cosmology to electronics and GPS technology. The theory of relativity actually consists of two distinct theories: special relativity and general relativity. Special relativity was published in 1905, while general relativity was published in 1915. Both theories are based on a set of simple, yet profound, principles that have been confirmed by numerous experiments. Special relativity. The first principle of special relativity is that the laws of physics are the same for all observers, regardless of their relative motion. This means that if you're moving at a constant speed in a straight line, you won't be able to tell that you're moving at all. Everything will look the same to you as it would if you were standing still. However, things start to get interesting when you introduce the second principle of special relativity. The speed of light is always the same, no matter how fast you're moving. This might seem like a bizarre and counterintuitive idea, but it has been confirmed by countless experiments over the past century. To understand the implications of these two principles, let's consider a thought experiment. Imagine that you're on a train that's traveling at a constant speed of 60 miles per hour. Inside the train, you have a flashlight, and you turn it on. According to the first principle of special relativity, everything inside the train is moving along with you, so the light from the flashlight should move away from you at the speed of light, which we'll call c. However, according to the second principle of special relativity, the speed of light is always the same, no matter how fast you're moving. So if you're traveling at 60 miles per hour and you turn on a flashlight, the light should still move away from you at the speed of light. It won't be going any slower just because you're moving. This might seem impossible, but it's actually true. In order to make sense of it, we need to realize that time and space aren't absolute, they depend on your perspective. Specifically, time and space are relative to the observer, which is why the theory is called relativity. The implications of special relativity are far-reaching and have been confirmed by many experiments. For example, scientists have observed that clocks on GPS satellites appear to run slightly slower than clocks on Earth due to the effects of special relativity. This is because the satellites are moving at such high speeds that time appears to move more slowly for them relative to the clocks on Earth. General relativity. While special relativity deals with how things behave in the absence of gravity, general relativity extends these ideas to include the effects of gravity. In general relativity, gravity is described not as a force, but as a curvature of spacetime caused by massive objects. To understand this idea, let's consider another thought experiment. Imagine that you're standing on the surface of the Earth, and you drop a ball. According to Newton's law of gravity, the ball falls to the ground because the Earth is pulling on it with a force called gravity. However, according to general relativity, the ball falls to the ground because the mass of the Earth is warping the fabric of spacetime around it, causing the ball to follow a curved path. This might seem like a subtle difference, but it has important implications. For example, general relativity predicts that massive objects like black holes can cause spacetime to become so warped that nothing can escape from within their event horizon, not even light. This has been confirmed by observations of black holes and their effects on nearby stars and galaxies. Another implication of general relativity is that time appears to move more slowly in the presence of strong gravitational fields. This is known as time dilation, and it has been confirmed by experiments involving atomic clocks placed at different altitudes on Earth. General relativity has also been used to explain the phenomenon of gravitational waves, which are ripples in spacetime caused by the acceleration of massive objects. In 2015, the Laser Interferometer Gravitational Wave Observatory, LIGO, detected gravitational waves for the first time, confirming another prediction of general relativity. Conclusion: the theory of relativity is a fascinating and groundbreaking theory that has had a profound impact on our understanding of the universe. Its principles have been confirmed by numerous experiments and have led to the development of new technologies like GPS and gravitational wave detectors. Despite its complexity, the theory is based on a set of simple and elegant principles that challenge our intuitive notions of time and space. It will continue to be a cornerstone of physics for many years to come. In addition to its impact on physics and technology, the theory of relativity has also had a profound cultural and philosophical impact. It has challenged our understanding of the nature of reality, time, and space, and has inspired new ways of thinking about our place in the universe. One of the most famous aspects of the theory of relativity is the idea of the twin paradox. According to special relativity, if one twin travels at high speeds while the other twin stays on Earth, the traveling twin will experience time dilation and will return to Earth younger than their stationary twin. This paradox has been used in science fiction stories and has inspired philosophical discussions about the nature of time and aging. The theory of relativity has also challenged our understanding of the relationship between space and time. According to special relativity, time and space are not separate and absolute entities, but are rather aspects of a single four-dimensional spacetime that depends on the observer's perspective. This idea has inspired new ways of thinking about the relationship between different fields of science, as well as new approaches to understanding the nature of consciousness and the mind. Finally, the theory of relativity has had a profound impact on our understanding of the universe as a whole. By describing the behavior of massive objects like black holes and the effects of gravity on spacetime, general relativity has helped us to better understand the structure and evolution of the cosmos. It has also inspired new theories and ideas, such as the concept of a multiverse or the possibility of time travel. In conclusion, the theory of relativity is a profound and influential theory that has challenged our understanding of the nature of reality, time, and space. Its principles have been confirmed by numerous experiments and have had a profound impact on fields ranging from physics and technology to philosophy and culture. Despite its complexity, the theory is based on a set of simple and elegant principles that continue to inspire new discoveries and insights into the nature of the universe. Thank you for listening to me.